Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're gonna talk about a neglected topic of compressors. So let's dive right into it. Now first we have to understand what exactly is this quote-unquote compressor. It is something that increases pressure of a gas. Now how the heck you can increase pressure of a gas? Basically by reducing its volume. So think of it this way. If there is a, let's say 1 kilogram of air in, let's say 1 kilometer square, you're gonna take same 1 kilogram of air and you're gonna pack that puppy up in 1 meter square. That's compressing it. Now you have to understand this. Air, aka the mixture of gases that we inhale all the time, and other gases like some refrigerants that we use in our air conditioning and refrigerators, those are very compressible. However, do not expect the same behavior out of a liquid. Almost no liquid can be compressed properly, and that is how we run a hydraulic system. So be very mindful. So if you try to use a compressor for a liquid system, boom will happen. So fundamentally this is a very critical aspect. Now what does this allow us to do? Okay, we took air, we took gases and we compressed it. What did it grant us? Well, it grants us the ability to transport gases. Basically think of it this way. If you have to transport, let's say LPG or some sort of natural gas and you have to pump it somewhere, you have to compress that puppy up. Otherwise, good luck trying to transport it. And if you want to store it, let's say you want to store basically tire air in a proper location, you have to compress it there. You do not if you do not want to run your compressor 24/7, that's the only way of doing it. And there is another interesting fact is happening. Once you are actually compressing it, you are expending energy. Basically you are taking your electrical energy and you are dumping it into air compressor. So what does that mean? That simply means that air now holds that the same amount of energy. Now again, total energy is exactly the same as your, like, let's say 5 kilowatt energy you burnt into your system. 5 kilowatt energy is there. It's just like by if you add about inefficiencies and all that jazz up, it would be like 3 kilowatt. So 3 kilowatt of energy is there inside that compressed air. Now you can utilize that as a power source. That is very critical, and kind of early industrial world was built on that. So we have a lot of pneumatic tools. Before we had proper electrical tools, cordless tools, we were relying on pneumatic tools. And heck, most of the places we still rely on pneumatic tools, because if you really want the oomph out of your tools, pneumatic tools have the largest amount of size and power ratio. Basically the drills would be ludicrously powerful. They will be very small, but because their energy is coming from something huge, they will be very powerful. Jackhammers running on compressed air. So same thing happens with this basically nail guns, pneumatic tools. Like there is a whole industry of this. So that's what we are talking about when you're talking about compressor. It allows us to charge a gas and dump energy into that. How do you use that? That's up to you. You can use that energy to transport, you can use that energy to do work, or you can just use that energy as a compression medium. It's like just compress, just stay there for a while. Now there are many types of compressor. Basically if you actually dive deep into this puppy, it's like wow, it's a rabbit hole. So to understand this, they are generally classified in two core categories. The category number one, dynamic compressor. Now dynamic compressor are generally, basically they have a chamber, but it's not quote unquote sealed. Basically compressed gas can backfire also, so to say. So think of it this way, a jet engine. Now if you look from side, you will notice the blades are getting smaller and smaller. However, at no point during the compression stage it's sealed. Like it can, like you can fire a compressed air from side, it will leave out. There is no quote unquote seal here. So this will be what we classify as dynamic compressor. Then how the heck this puppy works? It works on high speed. It relies on speed. If it does not have speed, it's not gonna work. It has to have the speed of the blade, it has to have forward moving air. All those things help it to compress air. Without it, it will simply leak out. So that's the one point. Now most of the time in your day-to-day life, only blowers will have this system, and jet engines will have this system, and centrifugal air blowers also have this. But most of the time we utilize what we call positive displacement. Now this has some ability to seal the chamber. Now it could be something very simple. It could be a piston with a one-way valve. It's like, okay, suck in, one valve lets the air in, then once trying to compress it, it actually compresses that puppy up, and then exit valve lets it out. So it could be a simple as that, or it could be something as geometrically complex as a scroll compressor, where it's like inherently it's doing that continuously. It's like just keep rolling it, like, but if you follow a groove there, you will see the volume of air is getting trapped there and it's getting compressed, and then coming out of the other end. So there is always a chamber that is sealed. Now if it's unsealed, basically there is no parts blocking each other, you are generally talking about dynamic compressor. And if it's relying on speed, it's generally dynamic compressor. If it's relying on, it can even work on slow speed, generally it's a positive displacement system. Basically you can see something like this in your car supercharger, not turbocharger, supercharger. So what are the uses of it? Now this is the part where the fact I said the compressors are very ignored. It's simply because every single field there is on this planet utilizes this. Every single industry utilizes this. This is not an optional technology. This is necessary technology. It's almost as ubiquitous as electricity. Basically, we don't think about electricity. We don't even say electricity is a technology. It's like it's a given for us. So compressor is the same technology. And recently I've been to a dentist, and I'm reasonably so you have seen something akin to this in a dentist, and the dentist drill that also works on compressed air. So that's the whole point. And industries, they rely on it. There is no other way of like freaking freezing something like big, like ice cream, or like other industrial processes that does require serious cooling, otherwise they will go boom. In those sort of scenarios, there is no other option. And in terms of like, you may say, okay, those are niche cases, doctors, engineers, industry. How about common people? Yes, Dave, if you utilize a car, there is a very good chance it has a compressor into it. If you used a fridge, there is absolute guarantee that it has a compressor into it. If you ever flown in a jet, it has a compressor into it. So reality is, it's absolute kind of technology. It's a technology that we have forgotten about, but it's really, really backbone level kind of strategy, so to say. Now, because of the role that it plays, it has become one of the biggest energy consumer there is at this point in the planet. Now, again, when I say energy consumer, I do not mean like, because energy consumer are divided in such a way, like, power consumption, cooling and heating would be a subsystem inside that. Then there would be like transportation industry. That way we have. But if you look that, given the fact that compressor is in every single industry, you will realize the fact that it is something important. It is like very serious chunk of energy that we generate is consumed by this puppy. So making this puppy efficient, it's a very serious money saving advantage. Now, nobody gives a damn about environment, you have to understand. But if you sell them, hey, do this and it will save you money, everybody will be like, shut up and take my money. So reality is, we are working very hard. Like recently there has been a resurgence on new designs that allows us to save money. Now, one example could be LG tried a very big gamble with a linear compressor. Now, linear compressor is the simple idea. Basically, if it's a piston and all it's doing is going back and forth, using that motion, trying to extract that motion out of a rotary motion, basically a motor going like this and then having a crank connecting to it, and that is like doing that's a lot of friction point. And LG had a very good presentation with like 4 friction point. Now imagine all you had is that piston and that is going back and forth. You have only 1 friction point. That's the whole point of linear compressor. It's just like we already have AC electricity in our homes. That is fundamentally sinusoidal. Basically, if you have electromagnet, it will go like this. So why not just use that? So they utilize this. However, that was like kind of a miss kind of scenario, because apparently their engineering department either failed or the project manager department failed. The valve used to keep breaking a lot. Basically, this compressor is supposed to last for freaking 20-30 years, and be mindful, these are non-repairable. The black casing you see, they are hermetically sealed and welded. You cannot tamper with them once it's done. So even if you have a minor break inside them, the end. And a lot of LG refrigerators broke because of that. Like, and they broke very early, as in like 1 year, 2 year, 3 years. And like type LG linear compressor, the first thing you will see is cutaway of people. Like the valves are breaking basically. LG did took a very big risk trying to achieve this, but apparently they messed up one very critical aspect. And because of the fact that it was irreplaceable, even if the cost of that valve would be very cheap, the problem was that you have to open a welded casket, reseal it. Yeah, that's not doable in like home appliance. So they did try that. And another aspect that is catching on very successfully, that is rolling piston design. And you will see like quote unquote rotary compressor. That's the whole point. There is a shaft and it has an unbalanced cam into it, and that cam is rotating in a cylindrical system. Now, benefit of that, the friction points are almost negligible unless you count about bearings, but bearings are designed to reduce friction, so that's not an issue. However, there is a vane there. Now, that vane is contacting the rotating element. Now, that's it. That's the only friction area. Instead of having like whole shaft being friction like this, you just have very little friction. Benefit, much higher efficiencies. So that is also becoming much more kind of prominent in home air conditioning units. Now, this is one thing that you have to understand that very thoroughly. There is no magic bullet, there is no magic solution. So all of these designs will have some good things, they will have some bad things, and it's a job of an engineer, job of a product manager to like actually, okay, this compressor is super amazing, but it costs 10 times more. Yeah, nobody's gonna buy that. It's like, yeah, we cannot use that. This compressor, super amazing. It just keeps breaking every 2 years. This compressor, really good, but it does require to use on high energy. You cannot utilize on low energy system. You have to find a quote unquote balance. That's why we have a saying, right tool for the right job. Do not expect because many times people kind of get lost in two ways. Like, hey, dude, if this compressor is so awesome, why don't we use this for everything? There is a reason for that. So be very mindful. Many times every company will try to sell you like, dude, we use scroll compressor, this is the most amazing thing ever. Dude, we use rotary vane compressor, this is the most amazing thing ever. Like, no, all of them have their pros, all of them have their cons. If it's perfectly fine-tuned, it's like, dude, you need this and this tool provides exactly what you need, amazing. If not, then you're gonna have an issue. So a lot of improvements are going on. So what we can expect in the future? Now, this is one thing that you have to understand. We realized very early on that all our electronics, almost till recently, they're running on bang control. Basically, you turn them on at 100%, you turn them off, on and off, on and off. There was no gradation control on that. So we realized that most of these systems, compressors, are relying on motor of some sort. Most of them have utilizing AC induction motor. Okay, AC induction motors are amazing, they're awesome, they don't have any frictional part, basically they don't have any brushes, they're amazing. It's just the problem is their RPM is directly locked with the frequency. So based on your design, based on how many poles you have, you will have a fixed RPM. Let's say 1600 RPM for 60 hertz. That's it, you can't change it. It's like you turn it on 1600, you turn it off 1600, like 1600 to 0. There is no controlling that. So we utilize industrial technology in that. We call that inverter. Now what the heck inverter is doing that? Now depending on designs, each design could do it differently. Most of the time they will take the AC current that is coming in, they will make it into DC. You will like, why the heck you want to do that? Well, you take that AC that is now DC, you make them into AC again. We're like, what the hell? Why the heck you went the extra route? That's like trying to feed yourself like this. The reason is very simple. If you are making the AC, you can control the frequency, basically hertz. This is fundamentally a VFD, variable frequency drive. You can tell the motor, bro, the person has come to the room, the person has triggered the air conditioner, the room is hot. Okay, you need to go full out. Now 60 hertz, that's good, but motors generally have a bit of oomph. So at that point in time, they will be like, okay, run at 75 hertz, go YOLO. So the moment the basically thermistors start to detect, okay, room starting to cool down. Now generally, if you had the old system, all you could do is turn it off. Okay, it's too cold. Now wait for room to warm up again. You don't have to do that if you have VFD, aka inverter. At that point in time, it's like, okay, now the room has reached the point. Let's say the person set it to 24 degrees Celsius. It's like, okay, 24 degrees Celsius is achieving. Okay, relax, compressor, relax. Now you will tone it down to 75 hertz to 60 hertz. It's like, you know what, temperature is still going down. Let's calm down a bit. Let's calm down. Let's come to 30. At that point, it's like, oh, okay, now the input energy and output energy is balancing it out. The compressor is no longer in bang control, and you can calmly sleep at night or without suffering from the, dude, it's too cold, or it's like, dude, it's too hot. Amazing, and consuming less energy. So lot of effort is being put into the system at this point in time. Another aspect is design of the compressor itself is no longer just like, okay, let's use new technology. No. What if we make even more improvement? For example, Samsung is going all out into this rotary compressor. They had one. What if we add two of that? Now you're like, why the heck? Because this is unbalanced weight. Fundamentally, this is a vibrator. That's what is used in old mobile phones or like game controllers. They have a motor, they have a mass, and that is unbalanced, and this song is starts to vibrate. So you are doing that on a metal system. Here's the problem with metals: they fatigue like crazy. So over time it will damage the motor, over time it will damage the bearings, over time it's basically bearing is kind of fighting. It's like, now again, bearings can handle that, but it's like waste energy. So what if you have two and you offset them? Now benefit of offsetting is the vibrations are compensated. Now if you have seen any animation of internal combustion engine, that's exactly what we do. It's like you never make sure all, let's say you have 6-cylinder engine, or not all 6-cylinder will be going boom at the same time. They will space it out depending on the design. It could be 30-degree apart, 180-degree apart, depending on the design. So they are doing the same thing. Now if they are 180-degree apart, they are canceling each other out. Basically they are at perfect harmony, so to say. So what is the benefit of it? Less friction for the bearings to fight. So bearings are no longer fighting, they're like just gliding. That improves efficiency. Now you may be saying, hey, we increase, now we have two vanes, wouldn't that increase motor consumption? Absolutely. You will have to put much bigger motor there at this point in time, but a little bit bigger. And benefit of that is now you have much higher throughput while having less frequency issues. Awesome. So we are going YOLO, like lot of engineering is going on at this point in time to make these systems much more efficient. Now one hard reality is that we are very good with this efficiency, but that's the problem. The next big change is very little. So it's like going from CFL. Basically, remember this: incandescent bulb to CFL was like whoa. It's like whoa, 100 watt of light bulb to 10 watt. Wow. Now 10 watt to 1 watt, that's not a big difference. And again, 10 watt you only go down to, let's say you're talking about LED, let's say 5 watt. Now again, it's still a 50% power saving, but it's no longer as significant as we used to. So same thing will happen with these things also. Like a single system does work. There are many industrial systems that are utilizing. There are many systems that have been running for 10-20 years. It's a known thing. Two, it will not just like magically, okay, now your electric bill is half, but it will help. So we are going chasing that last 1% of efficiency, but do be mindful. Do not expect like YOLO kind of energy saving. We have crossed that threshold at this point in time. So another aspect is that we are utilizing compressor. Now compressor, when you are talking about air conditioner, it's not actually a cooling device. All it is a heat pump. It basically takes the heat from the inside of the room and dumps it outwards. Now somebody came up with a very brilliant idea. What if we allowed the gas to flow in other direction? Now you may be like, why the heck you want to do that? Here's the deal: it will heat up the room. Now in winter, specifically in northern parts of the, basically anything that is above the equator, and you go closer to basically North Pole, you realize the people have to suffer cold. Like we Indians don't have much understanding of winter. Same way, basically American people don't have much understanding of summer. Basically their summer includes like temperature as high as 35 degrees Celsius. I'm like, bro, 52 degrees Celsius is normal for me. So you get the point. So reality is winter is also a very serious energy consumption. So at that point in time, if we utilize heater, that's 100% efficient. But what if we can go more than that? What if we can go to 200% efficient, 300%? Like, whoa, is free energy? No, because this is a heat pump. So all new modern air conditioning unit comes with the ability that you can reverse the gas flow, and instead of heating, heating the outside part, it starts to heat up the room and freezes the outside part. Now you do have to be mindful of the outside part, specifically if there is humidity. You could end up in a scenario where you freeze the whole equipment, but generally they have cut-off systems and all that jazz. But that's the whole point. You can achieve higher than 100% efficiency. You can achieve like 200, or practically speaking like 300 is achievable. So if you have something, even a low power air conditioner that is only consuming 1 kilowatt, multiply that by 3. That's an awesome amount of heating element if you for your house without consuming too much power. So we have very interesting future ahead of us, and compressors are coming back to the public consciousness. Like they are always there. It's just like somebody is now like, okay, let's try to extract 1% more out of efficiency out of it. So this was my presentation about a neglected topic of compressor. I hope you liked it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.